Hello everybody, I'm Marco D'Ambros, and this is the second part how to build a two bones array system in Maya. So in the first part we create what we call planar matrix, then is the m constraint, so the plot vector and everything works fine. And the second, and now that we have our planar matrix, we define our plane where we can build our 2D system for solve the angle of our triangle equation. So this is gonna be our triangle. You can see better, or you can read better about this one on my intro. So you come back on that video if you wanna see it. Actually, let me write properly. So we call this one len A and len B. So this means uh, this is A, this is B, and this is gonna be C. So the angle is gonna be A, B, C. We want to find this corner here, angle here. So the formula, this is a law of cosine or cosine rules, is going to be then b squared it's equal to a squared plus c squared minus 2ac cosine gamma. Or we can, no, or, and we need to find the angle. So the angle is going to be a squared plus c squared minus 2b squared divide by 2ac. So we need to find this one here. So let's jump in. And let's create a compound, and this compound is gonna be len A, len B, and length of this segment here is gonna be our C. Let's call this one segment A, segment B, segment C. There we go. Let's start with the output as usual. So value, this is going to be a matrix. Actually, let's find the matrix with SRT to matrix because we just need to change one angle. We can get the create node layer to quaternion, and this is going to be create value node. So now we have a vector 3 node, and we need to just change, set the values Z. So we need to start with the power. So let's go power by 2. It's going to be square, square, square. We need to sum all together, but b is going to be negative. So let's go negative. Add, 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 add. So we can go now for the multiplication. So it's going to be multiplied by A and C. Let's create a value, and this is going to be 2. So divide by our add and multiply. We can come back here later. So yeah, there you go. We need to just have a cosine and if. So now we have everything connected, and we have our matrix based on this rotation here. But we want to still have the parent matrix, so the planar matrix. So we're going to multiply matrix. This is going to be our father, that's going to be our son, and we can put this one here. And everything's for work fine. See, the angle is there, and our first steps is done. Let's fix just one thing, is when we reach the maximum length, everything explode. This because the range, oh, let's call this one angle A. This because the cosine A, we can even write a condition here to skip the 0, divide by 0. It's not something that has happened, but we want to do it. But the problem here is that this value, uh, the 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 range of cosine is 0 to 1. So when we reach more, it doesn't know what to do. So we can just write a condition greater when this one is greater than 1. If we can, or give the result of cosine actually, then or we can directly, yeah, we can do that. So we can say then when is greater than 1, it's going to be 0. We can keep this one like this. That's fine. There you go. And now it's work. Like I say, you can see in my video, I always prefer to have a node and represent the value if I want to change the setter. I don't want to change it because that is what I want, but in case I do prefer it this way. Okay, now we have everything good and works for the first one. It's great. Now let's do the second uh, corner. So the math is just absolutely the same. We just need to change A, B, C. So what we can do, we can get angle, copy and paste. So now we have a second one, and this is gonna be our angle B. So let's come back 1 second here. If you see the negative one, because it's easier, is our opposite, so B. So in this case, our opposite is this one here. So that's gonna be our B. The other two are gonna be the same, A and B. So now that we have this one, there is a couple of things we need to change. Let's start. Let's start to do everything there. So before, let's start to output here. So now we can come back on our node editor because we never connect B. So let's get B and let's plug B to our offset matrix. This is correct. It is correct. It's not correct, of course, but it's fine. So first things is just for visualization, I add here the length. So let's remove it. And now it's 0. 0 because we output 0, just the angle. So if you can see, the angle is kind of there, but not the output. So we can do something similar that. So we can create a value. That value is going to be a matrix. Even in this case, you don't want to do SRT just for one translation value. Translation is very simple to apply. So it's just easier, faster to, or lighter, sorry, use directly a matrix. So a matrix value and just change one field. So we want to have a matrix multiplication, this one by that one. There you go. Yeah, so this is just because it's 0. So let's put this on 1. Okay. And actually, if you want to see, we need to do this one here. Here we go. So, but what is this value? This value is literally our length here, A. So go there, there, length A is going to be X. So this means even when we are going to change this one, oops, sorry. We want to change the length of this one all the time as well. Okay, so but why now this angle is like this? So in theory, it's supposed to be right, but if you can see, it's not. And the reason is because we are working with always positive angle. We are not computed properly, etc., etc. So that is our segment, right? And now what it's doing is using this one as the positive angle instead to do that one there. So what we have to do is adding or subtract 180 because we want to reach that. I will show you. So we come back on angle B. When we have cosine, here you go. We can do even after if, doesn't really matter. We can, let's find pi, and we can subtract. I will show you both. It's absolutely the same. So this one minus pi, that is gonna be our condition here. Here you go. And now it's working properly. Even this one. Here you go. And that is actually works fine. Let me show you even with the add, because it's 180, it doesn't really change that much. So you can do this one plus that one. Here you go. See, nothing really changed. So you can change this one, work like this. Everything it works fine. When you are going to work with the quaternion here, the result is going to be absolutely the same. So 0.7. Actually, let me show you even the matrix there. So we have here minus 90. If I change with this subtraction, nothing changed. The value is the same. Is change, well, here, but after the when we jump on the quaternion and the matrix, this value is still the same. So you can choose wherever you prefer. There you go. So, and we have our two bones case system in Maya. Um, yeah, I'm going to do like a new video where I'm going to show with basic Maya node. Thank you very much to watch. See you next time, Marco.